I didn't shave, but I have been working this weekend on a reimagining of PyScript and Pyodide. And what I'm going to show is the biggest thing is writing custom elements 100% in Python. No need for JavaScript on that. Distribute them with Python as PyPI packages, and then just consume them as kind of these components expressed in markup in an HTML document. I'm also going to show kind of as in the course of things, moving all of the quote unquote PyScript part over to a web worker. So it runs in the background and dispatches back to the main thread using kind of a messaging interface. I'll also show one of the things I'm really interested in on this is the custom elements that you write. These components are 100% Python. They don't really call into Pyodide, so they don't call into the JavaScript engine at all. And what this will let you do is render on the server, because the way it is right now, if you have a custom element, if you have something in Pyodide, it'll be blank and then it'll flash. And this will give some options. If you're running a server to pre-render, if you're doing an SSG, you can pre-bake. If you have a build tool or some mythical in editor IDE kind of thing for PyScript, then you can pre-bake these things and substitute them. And then I'll show a couple of other things about component state being passed in through attributes. And all along the way, I'm not on Wi-Fi right now, so this is all showing 100% disconnected. Okay, onward. This is a demo of two custom elements. I'll go to my index.html and show that. A store greeter and a store customer with some information passed in as attributes. And then some buttons that are outside of the component that impact it, and another button that shows removing it from the document. How do these work? Well, I'll go show the implementation. So this is how you would write a custom element. This is how you would write store-greeter, store-customer. This is an example of an implementation. Could do a lot more with something like antidote and decorators and registrations and dependency injection, stuff like that. I left all that out for right now. So this is store.customer. If I change the name of it, you'll see one of them disappears. And we'll put it back because it no longer knew the definition of store-customer. I name the attributes, I name the rendering, so I could put XX there. And all the rendering is done as HTML that is returned over the messaging interface back to the worker, which then messages back to the main thread to draw on the screen. Point being, no element dot blah blah, where you are sitting in Python talking to something that isn't Python, which is imperatively talking back over the DOM. Later on, I'll get HTMX or morph DOM or something so you don't see that blinking like that. So that's how all that works. And then at the bottom, I've got another component. It's got a click handler. I should have shown that. Let's see. Did I put that back without the X? I'll get the XX out of there. Okay, so this is bringing up Pyodide. It's updating that custom element, and I can click on it to increase the counter. I can click on a button outside of the component to do it, and then I can do something that removes the whole component from the tree. What is it that's doing that handler? Well, that. And that's why you have to, in the registry, tell the automated machinery what events you are interested in. We'll take a look at the implementation of that. Okay, so that is the demo of how it works. I will, instead of starting from the endpoint in Python and working back, I'll start in the front point from JavaScript and work forward. I've got I will show the pre-rendering in a server part. So I have a Starlet process running. It's running on a port on 8000. What's interesting about it is I am as I render that page, which is nothing more than, it's not a template or anything, it's just the same HTML page that we were just looking at. What I'm going to do is I'm going to go find any element that has a dash in it, and I'm going to go to the Python side and render it, meaning that I'm going to pass in the attributes, render it, and then put the new content in. And so we can see that in action the best by turning off the Pyodide side. So I'll go, actually no, in vain. I'll go and turn off the initialization of Pyodide. Then I'll go back over to, actually I'll go to Chrome, and this is running. And you'll see it rendered, even though there's no Pyodide running. It pre-rendered. And so you don't get that blank of there's nothing here when you have something that can run the Python either in advance or on a request and generate. And it's the same implementation. I'll prove it. Go back to the counter and I'll say XYZ. Go back to the app. Restart it. And I get X, Y, whatever. Okay, with that in mind, let me put this back. Let's take a look at going outside in. I'll turn off this server so we don't have to look at that anymore. And I'll go back to the loader and put it back in place. So how does this all get kicked off? I've got an HTML document, and I'm going to load an ESM JavaScript file. That's what this does. I'm going to put defer on it so I don't have to do any of that IIFE or document add event listener for DOM content loaded. And then this is the kicking off point. This is the part that is running in the DOM thread. This is something that just shows how something outside of the whole universe can still grab things and talk to them through the attribute interface of the DOM. When I do this mutation, it kicks off the custom element, which is listening for changes. And then that messages over to the Python side, says something changed, and then re-render, gets the string back, puts it back in the document. But this is the main part. The way this works is it's going to have a web worker, which does all the Pyodide side. And then what this main JavaScript function is going to do is communicate with that worker over a messaging, a post, this post message interface where there aren't objects being shared, there aren't proxies, there aren't any cross-language communications or anything like that. And it kind of forces us into a mode of being more declarative and less imperative. And the messages it's going to send and the messages that it's going to receive are in kind of this little registry. So for example, this is kind of like the API for this. I'm going to render a node. And so this is something that can be called on the Pyodide side to tell the main thread, hey, go replace this node with this HTML. And these are the handlers that can be called from the Pyodide web worker side. Go get the definition of all known elements. Remember, that's in Python. If you want to write a new custom element, you don't write new JavaScript. And then rendering a node is over there as well. How do we do this? How do we make a new custom element without writing a JavaScript class? Well, what if we used something called a class expression to make fake classes on the fly? That's what we're doing. For every element in the registry, and I will go to the usage of that. For everything registered in Python, every element it knows about, go and make a custom element. And for the class, use the class that was created on the fly by this function. What is this doing? It's kind of tricky. It was kind of fun. It has a constructor that on the JavaScript side, as it's going to go into the DOM, it's going to have a stable unique ID, which is mirrored on the Python side. So the two have to be kept in sync. We don't want to make new instances all the time in Python. And then we're going to attach event handlers. This was kind of hard. This is an event handler that will be registered on the custom element for anything that the Python data class said it was interested in looking at. So for example, my store customer said, hey, I'm interested in click. So when there's a click event, call me. And then that will get mapped to this function using a serialization of the JavaScript data structure for the click event. All right, and then once we get this listener, when it runs, it's going to post a message handle event to the web worker. We'll see what the web worker is going to do with it because it then has to dispatch it to the Python side. When we get put into the DOM, we're going to do a couple of things. This is when we have the props available. So we're going to gather our attributes. So we're going to gather up those attributes. And now we have all the information needed to tell Python, hey, go construct an instance of a data class for me by posting a message called make element to the web worker. If we ever get removed from the DOM, which is this remove customer thing, we need to tell the Python side, hey, that instance that you were keeping track of, you can throw it away. And then this is where whenever the attributes change for this element in the DOM, collect them up, send the new value, message the web worker, which will then message Python and do everything else. All right. And then we have to, as part of the custom element contract, we have to tell the world what attributes on the node, on the element that we're interested in. So that's kind of the main thing. It's the thing running in the main thread. Its job is just collect up information and message the worker, which is where more of the stuff is being done. So let's take a look at it. It's going to have a series of things that it can be told to do. First, initialize Pyodide. That's an important one. In theory, reinitialize Pyodide, but I can't figure out Pyodide has some mistaken fossil information about resetting itself. Make an element and make an instance on the Python side and keep track of it. Get rid of it. Update it because the properties changed, and whenever an event happens on the DOM side, it's going to be messaged through to the worker, which is going to synchronize with the Python side. Okay, so with all that, and then handle any messages that are coming back from the Python side. Okay, with that in place, we are going to initialize. We're going to do the standard dance about firing up Pyodide. We're going to load something that would be like PyScript, the thing that's in common to everything. And then we're going to load an app. And we're going to tell the app to set itself up to register its custom elements. And one of the nice things about being a worker is you've got this thing called self, which is available everywhere that you can stash things on without having like global variables or something. And with all that in place, we've loaded all the information. Again, if we used Antidote or something, we would have a registry. So this is just mimicking a registry. We've collected all the information. Now we can go tell the DOM side, go register your custom elements. Now, what are the kinds of things that it's doing? It's rendering a node. So the Python side says, hey, this UID, I know you're over there. Replace yourself with this HTML. Making an element. So go to the Python side, make an instance of a class, and here's the information that goes in it. Updating an element, you got some changes to an attribute, tell the Python side, update element, tell the Python side that things have changed. Event processing is kind of a fun one. This is nice because you don't, in Python, have to write something in JavaScript and have this cross-language stuff, because that wouldn't work necessarily if you were pre-rendering in a Python process or trying to write a PyTest. All right. Now, we've got all these things in place. What does it look like on the Python side? I'll go to the loader thing. And what we want to be able to do is get a registry of all the known elements. I'll go over to the counter. When you write a little app in this idea, it's going to export a function saying, here are all the new elements. But it's going to run this function in the registry to register those new elements and put them in place. It would be better to have some better formalism on this. And then we do all the more interesting things. When we make an element, we're going to stash the instance of it in a local global scope mapping. And we're going to create an instance of the data class that was registered for this. And then we're going to render the HTML, and tell the other side, remember we're in Python now, we're going to return this string of HTML over to the web worker, which is then going to tell the main thread, go update this. Handle event is kind of fun. It's going to, this is a JS proxy object, so we need to get a Python representation of the event, the DOM event. It's going to get all that information and decide what to do with it. This will work most of the time. It might not work all the time, like custom events or something like that. So there's a plan B, which I won't talk about in this, but it's going to involve HyperScript and HTMX. Then we grab the node and we call the event handler for click or whatever it was that was done on this. Update element has some things about just updating and then re-rendering the instance. And then finally, I'll go to counter and talk about that a little bit. It's just a class. And when we said first and last, well, that's where it is, first and last. And it gets stored on this instance and remembered and can be re-rendered and re-rendered. With this in place, it just has a couple of things that I'll wrap up with. A couple of aspects that I like about this. I can write new PyScript things 100% in Python. I can test them 100% in Python without any JavaScript engine around. I can pre-render them on the server. I can run a static site generator and pre-render them to disk. I can pre-render them into a Python package so that you can get a cooked version of them while waiting for the updated version to arrive. This is a much more natural way to run things. Some of the other parts are still interesting, like running in a worker and stuff like that, but this was the heart of what I was trying to do.